welcome to Knowledge Decoder. And how are you all? I hope you all are good and you all are doing hard for the examination. Okay. Now we are starting our next session. Actually, the name of session is Mogambo series. Mogambo series is going on. Okay, I hope you have gone through all the lectures. Actually, whatever lectures I have uploaded before this lecture, okay, I hope you have gone through. Okay, let's start this session. A simply supported beam with a rectangular cross section is subjected to a concentrated load at mid-span. If the width and depth of beam are doubled, the deflection at mid-span will be reduced to. क्वेश्चन समझ रहे क्या बोल रहा है, क्या जा रहा है क्या? In the question, it is given that we have a simply supported beam, okay, and a concentrated load act at mid-span. Let's suppose that what would be the deflection? What would be deflection? Deflection, let's suppose that this point is C. Del at C would be PLQ upon 4080 upon EI. PLQ divided by 4080 EI. Okay. This would be your deflection at C, but in the question it is saying that width and depth of beam are doubled. Means what you have to do next? What you have to do next? You just have to elaborate the term I. Then what would you getting? Let's suppose that you will be calculating del C dash. You will be calculating del C dash. Del C dash would be PLQ upon 48 EI. I means BDQ upon 12. When you will elaborate the I, you will be getting BDQ upon 12. What you have to do next? B becomes 2B and D becomes 2D. And you will solve this question. Del C dash, I think del C dash when you will calculate del C dash, it will be having value like del C by 4 when you will calculating this. Okay. Actually, what you have to do, you just have to calculate and you will get your answer. Okay. And what you have to do, you just have to multiply by 100. When you will calculate this, what you have to do, del C dash, I think I don't remember. Actually, I have solved this question earlier on my pen and paper. Okay. Actually, don't remember. You just have to calculate del C dash. I cannot say that del C dash barabar del C by 4 100%. Okay. I cannot surely say. Just have to calculate del C dash, and you will having del C. The deflection at mid-span will be reduced to percentage. निकाल लोगे. Final minus initial but initial into 100. Okay. That would be what? That would be okay. When you will be increasing, like you will have del C and del C dash. When you want to use percentage decrease, okay, when you want to percentage decrease, final minus initial but initial to 100. But in the question it is not being asked how much it would be decreasing. It is asking deflection at mid-span will be simply del C dash, whatever you will be getting. I think you will be getting del C by 16. You just have to multiply by 100. You will be getting your answer. Okay. Let's move to the next question. A 3-inch symmetrical arch is loaded as shown in the figure below. Which one of the following is the magnitude of the correct horizontal thrust? We are having 3-inch symmetrical arch. This is your HA, this is your VA, this is your VB, this is your HB, this is your hinge, this is your hinge. Okay. Actually, this hinge tells you that M at C left is equal to 0. You can do this. M at C right is equal to 0. You can do this. Okay. You just have to first show the reaction. That is VA, that is HA, that is HB, that is VB. Okay. What you have to do, you just have to use summation of Fy is equal to 0, summation of H is equal to 0, summation of VA plus VB is equal to 2P. First equation you will be getting like this. Okay. H is equal to HB you will be getting. And what you have to do, you can also at point A, summation at point A, you can take it as 0. You can take it as 0. When you will put summation M at A is equal to 0, you will be having the term like this term will be cancelled out. You will be having P and VB. Again, M at C is equal to M at C left is equal to 0. You will be using these equations. First equation, second equation, summation m at a is equal to 0, and third equation mc left is equal to 0. Okay, when you will solve this, you will get your answer. Okay, let's move to the next question. In the question, in a composite bar of steel and copper, talking about steel and copper, and heated the copper bar will, let's suppose that this is our composite beam, this is our copper, and this is our steel, and you must be knowing alpha of C greater than alpha of S. Alpha of C greater than alpha of S, it means it will be having greater expansion. It will it would want to go like this, and it would want to go like this. But when it would be moving here to here, this will compels it to go here, to go in this direction. Means this copper will be having in compression, because this copper is subjected to compression. Means the copper bar will be under compression. And let's suppose that if it would ask in question, if it would be asked in the question that what would be the stress developed in steel, what would be the stress developed in steel when copper would be moving like this, when copper would be moving from here to here, it would tell steel to go here, to go in this direction like this. Means steel would be in tension. Okay, this would be your correct answer. For the copper, it would be in compression, because it is having greater expansion, greater coefficient. Okay, alpha, coefficient of thermal expansion. The fixed support in a real beam becomes the conjugate beam as in the fixed support, and when you will convert in conjugate beam, it would become free support. It would become free support. Okay, fixed support, it would become free support. Okay, if it would have asked about free support, then when you will converting free support, it would be converted into what? It would be converted into fixed support. The shear stress on a beam section is maximum. Shear stress, CSH distribution, and you must be knowing the CSH distribution. Actually, when you draw bending stress distribution, it looks like this, and when you will draw the shear stress distribution, it would look like this. Okay, means where the bending stress is 0, there the shear stress is maximum. Okay, the shear stress on a beam section is maximum at the neutral axis. On extreme fiber section, at the neutral axis of the section, at the free edge, your correct answer would be B. Okay. The deflection at the midspan of beam AB by unit load method. Actually, simply supported beam is given having UDL throughout the span. What you have to do, you just have to calculate the deflection at point C, and you must remember the formula 5 by 384 WL to the 4 upon EIE. No, this option is not matching, means none of the above. Okay, again, for the following cantilever beam, the change in clockwise slope A and B by moment area theorem will be, means theta A minus theta B, theta A minus theta B, or mod A theta A minus theta B बोल लो, it would be same. Okay, one thing is 100% sure, this is our fixed end here, theta A would be 0, and so whatever slope it would be causing due to this load. Okay, this load, and you must remember the formula. When there is a cantilever beam and having concentrated load at the frame, then your deflection would be PLQ upon 3EI, and your rotation would be PL square upon 2EI, PL square upon 2EI. Here P, here at the place of P it is written W. Okay, WL square upon 2EI. Your correct answer would be C. Okay, one more question. For a statically indeterminate pin jointed plane frame, the relation between M and J and M and J. Actually, when M is equal to 2J minus 3, it means for a statically determinate statically determinators. If you are getting m is equal to 2j minus 3, that would be statically determinate. Okay, when you are getting m greater than 2j minus 3, when you are getting m greater than 2j minus 3, that would be statically indeterminate. That would be statically indeterminate. M barabar 2j minus 3, that would be statically determinate, and m greater than 2j minus 3, that would be statically indeterminate. When m less than 2j minus 3, that would be unstable. That would be unstable. In the question it is being asked about the statically indeterminate. If m is equal to 2j minus 3, that would be statically determinate, but in the question it has been asked for statically indeterminate m greater than 2j minus 3. Your correct answer would be m greater than 2j minus 3 for a statically indeterminate structure. When it would be equal, when m is equal to 2j minus 3 for a statically determinate structure, when m greater than 2j minus 3, that would be a statically indeterminate structure. When it would be less than, then it would be unstable. Okay, what is the deflection of the midspan? Again, you just have to use the formula PLQ upon 48EI. Simply supported beam is given having load at the center. Your correct answer will be PLQ upon 48EI. Okay, section modulus for hollow circular section, outer dia D and inner dia D is. Okay, section modulus for hollow circular section, outer diameter D and inner diameter D is. Actually, is talking about section modulus. Then you must be knowing the formula Z is equal to I by Y maximum. Okay, I is equal to pi by 64 d to the power 4 minus d to the power 4, and Y maximum is equal to capital D by 2. Okay, that is pi by 32d d to the power 4 minus d to the power 4, means pi by 32d d to the power 4 minus d to the power 4. Your correct option would be B. Okay, the strain energy stored in a member due to bending moment m is given by integration of x square dx upon 2ei. It is simple formula. Influence line diagram can be drawn for only beams, arches, trusses, etc. Only arches, only truss. It can be drawn for any beam, arches, truss, etc. In two hinged parabolic arch, an increase in temperature will increase the horizontal thrust. If you are talking about two hinged parabolic arch, it will increase the horizontal thrust. The slope deflection in a structural analysis fall in the category of slope deflection method is equal to, you can say that slope deflection method or moment distribution method. These methods falls in the category of displacement method. Displacement method or displacement method is also known as a stiffness method. Also known as a stiffness method. Okay, your correct answer would be D. And force method is also known as flexibility method. Okay, the bending moment diagram for a cantilever whose free end is subjected to point load will be of shape. Simply, I already told you concentrated load, UDL, varying load, SFD would be 0 degree, 1 degree, 2 degree, BMD would be 1 degree, 2 degree, 3 degree. And the question is given that point load, it is talking about point load, and it is talking about to draw the bending moment diagram. Draw the bending moment diagram. That would be 1 degree. That would be 1 degree. Means you can say that parabola, rectangle, cubic parabola, triangle. Your correct answer would be triangle. That is 1 degree. Means your correct answer would be triangle. Your correct answer would be triangle, because it is talking about point load and it is talking about actually point load, concentrated load, UDL, SFD would be 0 degree, 1 degree, 2 degree, BMD would be 1 degree, 2 degree, 3 degree. And in the question that is point load, your bending moment would be of 1 degree. That would be triangle. Okay. Actually, we have done this question. Which of the following statement is correct for flexibility method of analysis? Flexibility method of analysis means force method of analysis. Means when ds less than dk, then we use force method. The method is used to analysis determinate structure. The method is used only for manual analysis. The method is used for analysis indeterminate structure with a lesser degree of static indeterminacy. Your correct option would be C. This A, B, C option could not be the correct option. Okay, Your correct answer would be the option C, ds less than dk. Okay. A fixed beam of a span is subjected to a uniformly distributed W per unit length if the beam has constant fragility, the fixed end moment. भैया ऐसा सीन है, WL square upon 12. Again the ratio theta and theta b. Again a simple beam is given and having UDL throughout the span, you have to calculate theta a by theta b. Okay. Let's suppose if it would ask to calculate the deflection at point C, let's suppose that this is the point C, then del at C would be 5 by 384 WL to the 4 upon EI. But in the question it has been asked about the theta A and theta B, means slope, and theta A is equal to theta B. It is 100% sure because this is our symmetric. This is symmetrical. Okay, theta and theta B would be WLQ upon 24 EI. Okay, and it is talking about ratio theta and theta is equal, means when you will be taking the ratio, you would be having the answer 1:1. Would have the answer 1:1. Okay, let's move to the next question. A Rankine's formula is used for the analysis of a steel compression member if the slenderness ratio L by R, lambda greater than equal to 88. I think none of the options are matching with it. Okay, the most commonly used admixture which increase the workability of concrete is called plasticizer, retarder, accelerator, air entraining agent. Plasticizer would increase the workability of concrete. The water cement ratio is expressed by based on volume of material, based on weight of material, because when you express the water cement ratio based on the weight of material, there will be no fluctuation. Okay, so water cement ratio is expressed by based on weight of the materials, Okay, as per IS 800, the buckling class for hot roll tubular section, actually it is written in the code and you must remember this. For hot roll tubular section, it would be fall in the class A. It would fall in the class A. Okay, it would fall in the class A. This is your next question. Increased height of building or room give better ventilation due to cross ventilation, wind effect, stack effect. Due to stack effect, room give better ventilation. Okay. Next question. Consider the following which of these are correct. High water to cement ratio in concrete results in high water to cement ratio, means water is more. Stronger mix, it would not be correct. Better workable mix, yes, you can say it correct. Weak mix, you can say it. Less bleeding, no. If water is more, then there will be more chance for bleeding. Your correct answer will be 2 and 3. The role of super plasticizer in a cement paste is to disperse the particles and to remove air bubbles, disperse the particles, remove air bubbles and to retard setting. These all three works will be done by super plasticizer. Okay. Consider the following stage in the manufacturing of bricks. Actually, you have to choose the correct sequence. Actually, we first want weathering, another one tempering, and the last we want molding. Okay, 1, 3, 2. Your correct answer will be 1, 3, 2. Okay. Which of the following material offer greater resistance to cracking or disintegration when subjected to fire? Asbestos, cement. That is simply. Okay. Agonic lines. Actually, I have done this question earlier. Okay, agonic lines. Actually, you just before going to agonic lines, you must be knowing about isogonic lines. Isogonic lines, like for equal declination. For equal declination, we use isogonic lines. When it is agonic lines, means it is for zero declination. Your correct answer is same declination. No, isogonic line would be having line connecting of same declination. Okay, line connecting zero declination, your correct answer would be for agonic lines. And this term has also meaning line connecting Like when it would ask about the line connecting the equal deep, line connecting the equal deep, then your answer would be isoclinic lines. Isoclinic lines. Okay. When it would ask about equal deep, when it would ask about equal deep, then your correct answer would be isoclinic lines. Okay. Let's move to the next question. Variation of bending moment in the portion of a beam carrying uniformly varying load. Again, what you have to do, you just have to do it first. Concentrated load, UDL, varying load. SFD would be 0 degree, 1 degree, 2 degree. BMD would be 1 degree, 2 degree and 3 degree. And now just go through the question. Talking about bending moment. Okay. For the uniformly varying load, talking about this, that would be 3 degree. That would be 3 degree. Constant linear parabola, cubic parabola. Should be your correct answer. Which one is not the fundamental line of a theodolite? Horizontal axis is the fundamental line of sight, vertical axis of altitude level. Okay. And in the surveying itself, I will be teaching you actually fundamental line relation may ask in your exam like this. This is your horizontal axis, this is your axis of plate level or axis of stride level, this is your vertical axis, this is your line of collimation, and this is your axis of altitude level. Okay, relations are very important. It may ask in your exam. Okay, you just have to remember this. Floor area index. Floor area index is covered area of all floors by plot area by into 100. It is actually easy if someone don't know about the floor area index, but if he use some mind, then definitely he can get it correct. Okay. Refraction error is curvature error 1/7 of curvature. Actually, if you remember the formula, then you can answer this question. Curvature correction, if you know, curvature correction CC बराबर minus 0.0785 d square meter. That is curvature correction. Your refraction correction would be plus 0.0 CC बराबर minus 0.0785 d square meter. That is d square meter d in kilometer. CR is equal to plus 0.0112 d square meter. Actually, the relation would be when you will be dividing it by 7, then you will be get this CR. Okay, so your correct relation would be 1/7 of curvature error. CC is equal to minus 0.0785 d square meter. What is the percentage of fine aggregate of finest modulus 2.6 to be combined with coarse aggregate of finest modulus 6.8 for obtaining combined aggregate of finest modulus 5.4? Actually, percentage fine aggregate. Actually, what you have to do? Percentage fine aggregate. You have to use this formula. FM of coarse minus FM of combined. FM of coarse minus FM of combined divided by, actually you can also say that FM of combined minus FM of coarse. You can say that, but you have to take it as positive. Okay, for better understanding, you can do it FMC minus FMC. You must be remembering this. Okay, it would be easier to remember by this FMC minus FMC. You may use FMC minus FMCM, मतलब FM coarse minus FM combined or FM combined minus FM coarse, but you have to take it as positive. Divided by, in the numerator, in the denominator, you have to remember FM for combined minus FM for fine. Okay, and multiply by 100. Means your formula would be percentage fine aggregate is equal to FM of C minus FM of combined or FM of combined minus FM of coarse. Okay, actually whatever you want to use, you can use it, but you have to take it as positive. Divided by नीचे what you have to do, FM of combined minus FM of fine into 100. Okay, everything is given. What is the percentage of fine aggregate of finest modulus? 2.6 means FM of fine is given. We combined with coarse aggregate of finest modulus 6.8. Okay, combined with the coarse aggregate of finest modulus 6.8. Actually, FM of coarse is also given. And of combined aggregate of, actually FM of combined is given. Everything is given. You just have to use FMC minus FMC divided by FM of combined minus FM of fine into 100. Okay. In trigonometric levelings, reciprocal observation eliminates instrumental error, refraction error, cross error, compensating error, refraction error. It eliminates refraction error. Which of the relation is correct? M barabar sigma into Z. Combined correction for a distance of 3 kilometers approximately. Actually, I already told you CC barabar minus 0.0785 d square meter, CR barabar plus 0.0112 d square meter, and when you will add this, you will get your combined correction, and combined correction would be minus 0.0673 d square meter. Just have to use this 3 kilometer. You have to put it here, and you will get your answer. You have to just add it. You have to just add it. Okay. Okay. Minus 0.0785 plus it. Now when you will add this, you will get minus 0.0673 d square meter. Okay. When you will put the value of d here, you will get your answer. Okay. Let's move to the next question. P barabar 2 pi nt by 60. P barabar 2 pi nt by 60. N would be in RPM. Okay. And P would be in watt. But in the question it has been asked. About the kilowatt. Means if you want to change it in kilowatt, you have to divide it by 1000. Okay. You will get your option C. Okay. Now thermal stress E alpha delta T, your correct answer would be. Actually, again, if the relation is given T by IP barabar tau by R, T by IP barabar tau by R barabar G theta by L. Okay. IP can be also written as J. Okay, everything is given. You can find it the relation from here. Okay. Is the Young's modulus size the moment of the maximum deflection of cantilever beam of length carrying a considerable PLQ upon 3I. PLQ upon 3I here, but P is not given. Here W is given. WLQ upon 3I. WLQ upon 3I. Okay. Let's move to the next question. E is the modulus of elasticity and I is the moment of inertia. Then the flexural rigidity or flexural stiffness of the material, EI. Flexural rigidity is known as EI. L is the length of the column, then the equivalent length of the column for one end fixed, other end free. L is barabar 12. Your effective length would be 12. Okay. In plastic analysis, the shape factor for a triangular section. For triangular section, it would be 2.34. For diamond section, it would be 2. For a square section, it would be 1.5. Okay. Actually, diamond section is very important. These diamond section questions, I think 5 to 10 exams have been asked. 5 to 10 exams have asked these questions. Okay. Okay. Actually, the Young's modulus of elasticity and actually what it would be showing. Okay. EI into dq upon dx cube. Okay. Actually, EI into d square y upon dx square is equal to m. EI into d square upon dx square is equal to m. What you have to do? Actually, here you are getting dq upon dx cube. What you have to do next? You just have to differentiate it one time. You will get EI into dq upon dx cube is equal to dm upon dx, and dm upon dx is equal to shear force. Your correct answer would be shear force at the section. Okay. The plastic section modulus of a rectangular beam section 10 mm depth. You just have to do plastic section modulus. You just have to draw it here. Okay. it is A1, it is A2. ZP is equal to, you will be getting A1 Y1 bar plus A2 Y2 bar. Okay, you will get your answer. Influence line diagram for a reaction at a support for a simply supported beam is triangle with simply how we draw influence line diagram. When we have to calculate the influence line diagram for reaction at A, what you have to do is we have to displace it by 1 unit and it would look like triangle. What we have to do, whenever you want to calculate the influence line diagram due to reaction, what you have to do, you just have to displace it for 1 unit and it would look like a triangle, and triangle with ordinate at that support. Okay, one more question, actually matching type, GN slope deflection method, Hardy-Cross method, moment distribution method, Euler's method, crippling load on column, Calibron for 3 moment theorem. Okay, you can match it from here. Okay, everything I have written here. Okay, you can match it. Okay, now signing off, this is Saurabh. Okay, you just have to do what? You just have to do work hard. Okay, whatever you are getting from us, you just have to read throughout the session and you just have to revise it properly. Okay, you will be able to solve each and every question. Okay, there will be, I think there will be no question you would not be able to do. Okay, hope you all understand this session. Okay, if you feel understand, if you understand all these things properly, just hit the like button and subscribe the channel. Okay, bye, love you all.